likewise. In this video, let me discuss about odd and even functions under Fourier series. Here I am going to take an example. Expand f of x equal to absolute sin x as a Fourier series in an open interval minus pi comma pi. Before when we enter into the problem, now we have a short look over the formulas that we are going to use in the given problem to find the Fourier series representation of the given function f of x equal to mod sin x. The first one you should know is integral u v dx. It's a Bernoulli's formula, that is, if you have the product of functions in the integration, then to evaluate that integral, we make use of this formula. That is, integral u v dx is equal to u v1 minus u dash v2 plus u double dash v3 minus etc. Here both u and v are functions of x. Here u dash represent the first derivative of u, that is du by dx, and u double dash represent the second derivative of u, that is d square u by dx square, and u triple dash represents the third derivative of u, that is d cube u by dx cube etc. So u dash, u double dash and u triple dash are successive derivatives of u, whereas v1, v2 and v3 are successive integrals of v. v1 is nothing but integral v dx, that is you have integrate v once again with respect to x, that is your v1. v2 is nothing but you have to integrate twice with respect to v. Instead of doing like this, already we have to integrate once, that is your v1. So you have to once again integrate that with respect to x, it gives you your v2. And v3 is nothing but integrate v 3 times with respect to x. Instead of doing that, already we have to integrate 2 times. So once again you have to integrate v2 once again with respect to x, that gives you your v3. So v4 etc. So v1, v2, v3, v4 etc. are successive integrals of v. And one of the trigonometric formula you should know here is sin 2a is nothing but 2 sin a cos a, and also you know these already, I think so. Sin of minus theta is nothing but minus sin theta, whereas cos of minus theta is nothing but cos theta. And the basic trigonometric and integration formulas we should know here is integral x bar n dx is equal to x bar n plus 1 divided by n plus 1, whereas d by dx of x bar n is equal to nx bar n minus 1. And integral sin x dx is equal to minus cos x, whereas integral cos x dx is equal to sin x dx. Sorry, only sin x alone. And integral sin 2x dx is nothing but minus of cos 2x divided by 2. So the general formula for integral sin x dx is nothing but minus of cos x divided by n. Whereas integral cos 2x dx is nothing but sin 2x divided by 2. So the general formula, that is integral cos x dx is equal to sin x divided by n. So the important trigonometric formula here we are going to use is to either we are having these products inside the integration, we make use of these trigonometric equalities to convert the integral into a simple one. So that is 2 sin a cos b is equal to sin a plus b plus sin a minus b. So these are the formulas you know already. So from that we have to derive these, right? That is sin a plus b is equal to sin a cos b plus cos a sin b, whereas sin a minus b is only the sign here changed. Whereas cos a plus b is nothing but cos a cos b minus sin a sin b. Whereas cos a minus b is nothing but cos a cos b plus sin a sin b. If you are going to add these two, what happened? So opposite side, these two being cancelled, so you get 2 sin a cos b is equal to sin a plus b plus sin a minus b. Suppose if you have to subtract these two, what you get? You have to get the second term, that is 2 cos a sin b is equal to sin a plus b minus sin a minus b. The same thing we have to do for the cosine. Cos a plus b, just add these two. Adding these two gives you 2 cos a cos b, that is equal cos a plus b plus cos a minus b, and subtract this from this. Cos a minus b minus cos a plus b gives you 2 sin a sin b. So you should remember these. Next, the values for cosine and sine. Cos 0 value is 1, whereas sin 0 value is 0. Cos pi is minus 1, whereas sin pi is 0. Cos n pi value minus 1 whole power n, whereas sin n pi is 0. So cos n plus 1 pi. So you know the formula for cos a plus b. Cos n plus 1 pi is nothing but cos n pi plus pi, right? You just take pi inside. So this is from cos a plus b. Cos a plus b is nothing but cos a cos b minus sin a sin b. Just substituting here, you get this value. So for this one, I have to evaluate and work out this value for you. Cos a cos b is nothing but cos a plus b is nothing but cos a cos b minus sin a sin b. Instead of ab, here you have n pi n pi. So cos n pi value you know minus 1 whole power n, cos pi minus 1. whereas sin pi both are 0, so we doesn't have the second term. That's why you have cos n plus 1 pi is minus of minus 1 whole power. And likewise you have cos n minus 1 pi, the same formula, instead of plus here you have minus. But here for the second one, here you have plus 0 or minus 0, whatever that be, same value for cos n minus 1 pi 2. Whereas sin n plus 1 pi 0 and sin n minus 1 pi also takes the value 0. Now, one more thing we have to remember while evaluating the trigonometric functions in Fourier series. In finding the Fourier coefficients a and b, and the denominator consists of the term n square minus 1. So you go for the particular case, that is you have to calculate the values of a1 or b1 as a particular case, and otherwise there is no need of calculating this. Okay, so this occurs only in case of evaluating the trigonometric functions. Okay, now let me now enter into the problem. Expand the given function f of x equal to mod sin x or absolute sin x as a Fourier series in an open interval minus pi comma pi. So first what we do, write down the given function. The given function f of x is absolute sin x, or you can say it as mod sin x. So absolute sin x, I told you already, whenever you are going to write the function, you have to write the function along with the interval. That is very must. So this is defined in an interval minus pi less than pi. As I told you already, the case of odd and even functions arise only for the intervals of type minus pi comma pi and minus l comma l. And the case of odd and even function doesn't arise for the functions defined in intervals of type 0 comma 2 pi or 0 comma 12. So the odd and even function doesn't arise for these two intervals. Only we have possibilities for minus pi to pi and minus l to l. So whenever your function is given, you have to immediately check in which interval the function is defined. The function is defined in an interval minus pi to pi. So if it is minus pi to pi, immediately you can verify whether the given function is odd or even. So further what you do, you have to replace x by minus x. So if you replace x by minus x, what happens? F of minus x. Here you have x, here you have x. That is absolute sine of minus x. So you know sine of minus theta. What is sine of minus theta? Just now I told. That is minus sine theta. That is minus sine x. Absolute value of minus sine x is nothing but sine x itself, isn't it? So this is nothing but your f of x. So what we get, if you replace in the function x by minus x, you get the same function, which means f of x is an even function defined in an interval minus pi comma pi. So which means the Fourier coefficient being 0, isn't it? So for more details about odd and even function, the link is given in the description box. You can refer the link for more details. Now, if it is an even function, let me show you the table, formula table. So leave the first one because we are not discussing the pi form in the interval of time 0, 2 pi. So now we have discussed under the problem under minus pi comma pi. In minus pi comma pi, we have three cases, whether the given function is of even type or odd type or neither even nor odd. Now we are under this category. The given function is of even type. If it is of even type, we calculate only a naught an and the value of bn 0, isn't it? So the required Fourier series b f of x is equal to a naught divided by 2 plus sigma n is from 1 to infinity a n cos n x, where a naught is calculated by making use of the formula 2 by pi integral 0 to pi f of x dx, and a n is calculated by making use of the formula 2 by pi integral 0 to pi f of x cos n x dx. Let me first calculate the value of a naught. So for that we make use of the formula a naught is equal to 2 by pi integral 0 to pi f of x dx, that is equal to 2 by pi integral 0 to pi, where f of x is nothing but absolute sin x, isn't it? So in the interval 0 comma pi, absolute sin x takes the value sin x itself. Okay, in the interval 0 to pi, absolute sin x takes the value sin x. So in my next step, what I do, in 0 to pi, absolute sin x is nothing but sin x itself. So sin x dx, integrating sin x, what you get, minus cos x, isn't it, with the limit from 0 to pi. So now let me substitute the limit, upper limit minus lower limit, isn't it? So upper limit minus cos pi minus of minus cos 0. What happens? You know the value of cos pi, 2 by pi. Cos pi value is minus 1, whereas cos 0 value is 1, isn't it? So these are our values you know already. So minus of minus, that is, I just write it, minus 1, and minus of cosine 0 value is 1. What you are going to do, this minus and minus becomes plus, this are minus and minus becomes plus. So what happened? So your a naught is equal to 2 by pi 1 plus 1, isn't it? That is 2 by pi 2, that is 4 by pi. This is the value of a0 we have calculated. Now what we do, next we calculate the value of a. For that we make use of this formula 2 by pi integral 0 to pi f of x cos n x dx. As I told you already, 2 by pi integral 0 to pi f of x is nothing but mod sin x cos n x dx. As I told you already, in the interval 0 to pi, absolute sin x takes the value sin x itself. So what you are going to do, that is 2 by pi integral 0 to pi sin x cos n x dx. What I am going to do is, I am just interchanging the portions of sin and cosine for a simplification of calculation. Okay, that's the only reason. So I have to take cos as the first term and sin as makes next one. Okay, so this is of the form cos a sin b, isn't it? You know the formula 2 cos a sin b. Just now I give you. So 2 cos a sin b is nothing but sin a plus b minus sin a minus b. Instead of a here we have nx and b here we have x. That's the only difference. So here we have only cos a sin b. So what you are going to do, you just take this 2 to other side. So what I am going to do is 2 by pi integral 0 to pi cos a sin b is nothing but sin of a plus b, that is nx plus x, minus sin of a minus b, that is nx minus x, whole divided by 2 dx. Here 2 and 2 being cancelled, isn't it? And next step, that is equal to a, that is equal to 1 by pi integral 0 to pi sin of. So what your first term is nx plus 1. I have written it as n plus 1x. I just take x outside. So n plus 1x minus sin. Here itself you have to take x outside. N minus 1x. That's all. Now what you are going to do? Just simple integration, isn't it? So no need of any Bernoulli's formula. You have only simple integration. So sin n plus 1x is nothing but, suppose if you are confused to integrate this continuously, so you have to separate. I have tried it one more step. Integral 0 to pi sin of n plus 1x dx as one integral, minus 1 by pi integral 0 to pi sin of n minus 1x dx as the second integral. Okay, so you can separate this integral. Okay, now integrating what you get, sin of n plus 1x is nothing but minus cos of n plus 1x divided by n plus 1. With the limit from 0 to pi, minus 1 by pi, sin of n minus 1x, while you are integrating what you get, minus cos of n minus 1x divided by n minus 1. With the limit from 0 to pi. Now, let me now substitute the limits. So, as I told you already, minus cos n plus 1 pi. Cos n plus 1 pi value is minus of. So here we have minus cos n plus 1 pi. What is the value of cos n plus 1 pi? That is equal to minus of minus 1 whole power n, isn't it? So we make use of that. Okay. So minus of minus 1 whole power n. So upper limit over. Coming to the lower limit. What is your lower limit? 0. So if you replace x by 0, what happens? Minus of minus plus cos 0, 1. So the denominator is common, that is n plus 1. Isn't it? Minus 1 by pi. Here itself the same process. So instead of n plus 1, here you have n minus 1, right? So upper limit cos n minus 1 pi. Cos n minus 1 pi is also minus of minus 1 whole power n. So minus, here already you have minus. So minus of minus 1 whole power n. Upper limit over minus. Coming to the lower limit 0, cos 0 value 1, already here you have 1, sorry minus, so minus and minus becomes plus 1, divided by n minus 1, that's all. Simplifying this, you get the value 1 by pi, so here you have these two minus becomes positive, so minus 1 whole power n plus 1, divided by n plus 1, minus 1 by pi, minus 1 whole power n plus 1 divided by n minus 1. So here you take the common terms, okay. outside. So what you are going to do? Minus 1 whole power and plus 1 divided by pi. It's a common term. You take it outside, what you get? 1 by n plus 1 minus 1 by n minus 1. So simplifying by taking LCM, what you get? Minus 1 whole power n plus 1 divided by pi. So n minus 1 minus n minus 1. N square minus 1. So plus n and minus n being cancelled. So you get minus 1 whole power n plus 1 divided by pi. Within that you have minus 2 divided by n square minus 1. So this is the value of an you have calculated. So one more thing you have to remember, whenever you see minus 1 plus 1 like this term, so you can divide this as odd and even term separately. So I am just substituting the value 1, that is odd value. If you substitute odd value, what happens? Minus 1 whole power 1 is minus 1 plus 1. So the entire term becomes 0. So entire term becomes 0 if n is odd, isn't it? And if you substitute even terms, 2, 4, 6 like that, if you substitute n is equal to 2, what happens? Minus 1 whole square, that is plus 1. 1 plus 1, 2. So plus 2. So you have to multiply, that is minus 4 divided by pi of n square minus 1. If n is even. So the value of n exists only for even numbers alone, not for odd numbers. So look at the denominator of an. Here the denominator of an consists of the term n square minus 1. If the denominator consists of the term n square minus 1 means we have to move for the particular case. That means we have to calculate the value of an. A1, which means this is a formula for an. In formula for an, just replace n by 1. So what happened? You get the value of a1. a1 is nothing but 2 by pi into 0 to pi f of x cos x dx, isn't it? That is equal to 2 by pi into 0 to pi. 0 to pi absolute sin x, that is nothing but sin x itself, cos x dx. You know the formula, sin 2 is equal to 2 sin a cos a, isn't it? So instead of 2 sin a cos a, you have only sin a cos a. So I have to replace this by 2 by pi into 0 to pi sin 2a divided by 2 dx. So 2 and 2 being cancelled. So here you have a1 is equal to 1 by pi into 0 to pi sin 2x, isn't it? Sin 2x dx. That is equal to 1 by pi. Integrating sin 2x, we have minus of cos 2x divided by 2 with the limit from 0 to pi. So substituting upper limit minus lower limit as usual, what you get? And also you have to take this minus to outside. So cos 2 pi. Cos 2 pi values minus, and also you can take 2 to outside. Okay. So minus 1 by 2, you have to take it outside. So you have only cosine 2x. So cos 2x. Cos 2 pi values plus 1. Whereas upper limit minus. Coming to the lower limit, cos 0. Cos 0 value is also 1. 1 minus 1, 0. The value of a1 is 0. So now let me substitute all these values in f of x, gives you the Fourier series representation of the given function f of x. So this is equal to a naught. What is the value of a naught we have calculated? That is 4 by pi, isn't it? Divided by 2 plus. So before that, I just split this for your clear understanding. So in the summation, you have to take the first term outside. Okay, that is a1 cos x plus sigma n is from 2 to infinity an cos nx. Okay. Now your a naught is 4 by pi divided by 2 plus a1 value 0, the second term 0 plus n where here sigma n is from 2 to infinity, but an takes only even numbers, that is n takes the values even numbers to infinity, which means n takes the values 2, 4, 6, etc. to infinity. So the value of an we have calculated is minus 4 divided by pi of n square minus 1 cos nx. Okay, that is equal to here one of the 2 being cancelled. So you have here have 2 by pi, that is your f of x equal to 2 by pi. Here the summation is only for n terms, so you have to take minus 4 by pi outside. Minus 4 by pi, sigma n is from 2, 4, 6, etc. to infinity, or you can write it as even terms to infinity. Okay, both are same. Cos nx divided by n square minus 1. So this is the Fourier series representation of the function f of x equal to mod sin x, that is absolute sin x defined in interval minus pi comma pi. Hope you got a clear idea about how to find the Fourier series representation of a trigonometric function defined in an interval minus pi comma pi. Thanks for watching. See you all again in my next video.